All right, let's zoom on in and let's get started. All right, so today we're going to be doing rational functions. And so a rational function is just a polynomial or a polynomial. And so we're going to go over a bunch of different concepts right here. Um, so we're going to graph this, which we know how to graph this. We already know what the graph looks like. We're going to be looking particularly at values around 0. Um, and what are the values when it's approaching from 0 from the left and 0 from the right? And so this means coming in from the left side. This means coming in from the right side. This means going out as far as we can left and as far as we can right. All right, so I'm going to choose a couple points. So let me choose a couple points here. So we want to look as it gets close to 0. So here, let's have negative 0.1, and then we're going to have negative 0.01, and then I'll have positive 0.01, and then 0.1. So this is as it's going into 0, right? This is looking at 0 minus. This is looking at 0 plus. So basically 0 minus means coming in from the more positive side. I guess more positive is a terrible way of saying it. From the right side and from the left side on the number line. So we're looking at 0. At 0, this is undefined, but as we get close. So what are those numbers? So here, if I have 0.1, 1 divided by 0.1 is 10. 1 divided by 0.01 is 100. 1 divided by negative 0.1 is minus 10. And 1 divided by negative 0.01 is minus 100. Okay. All right. So here, we already know at 1 it's 1. And so here it's up to 10 and then to 100. And so we can write in the following, right? So as x, and we'll write it as this way, as x approaches 0 negative, y approaches minus infinity. Because notice if we put in 0.001, I'd get minus 1,000. As x approaches 0 positive, y approaches positive infinity. And so we use these little signs to mean approaches, which you're going to do in calculus, just so you know. Or as, let me write this out, approaches approach 0 from the left side. And this is from the right side. Approaches from the right side. Okay. Oops. I don't need ditto marks here because I need 0 positive. Okay. What we're going to do, what you do in calculus, you say the limit as x goes to 0 negative of our function 1 over x is equal to minus infinity. So this is literally kind of what taking a limit is, more or less. For those who took a little bit of calculus, you should recognize this. For those who go to calculus, you'll soon recognize this, right? And so we're just going to kind of and how we do it in this section is we're just testing numbers, right? We're not going to do any fancy math way of doing it. We're just going to test numbers, okay? All right, so what's the other thing we want to test? So let's say if x is negative 100, well, that's going to be 0.01, and here if x is a positive 100, so we'll get positive 0.01. And if it was 1,000, it'd be 0.001. Okay. And so the other things we want to say here is that x approaches infinity, right? So as x gets larger and larger and larger, we're going to say y approaches 0 because this number gets smaller and smaller and smaller. As x approaches minus infinity, y also approaches 0. So here we have, as we go towards negative infinity, this thing's going to slowly and slowly become closer to zero. As this gets closer to the zero, it's going to slowly get more to infinity. Here, as I go out to positive infinity, it gets more and more close to zero. And here, as I go up to the zero from the right side, it gets up to positive zero. Okay. And so this is just looking at the most basic one. So I'll let you guys copy that down. And then I'm going to kind of describe how to do this in a more general sense. But I wanted to be very clear on why this thing all of a sudden just splits, goes right. Because once you understand, why it does this, because once it gets really close, if I divide something really, really small, right, it gets really, really large. And if I divide by something really large, it gets really small. So let's start applying this to some more generalized things. And the one thing I'm trying to do in this class is get you very used to generalizing, going from specifics to generalizations, right? So here we saw a specific case. Now we're going to try to generalize that. It's kind of like how I showed you, here's what x squared and what x to the 6 looks like. What does x to the even power look like? To generalize stuff, right? It's a powerful thing to have and to use. So here, if we have x equals to a, be a vertical asymptotic line. Oops, hold on. And if y approaches positive and negative, so here, if we have some sort of asymptotic line, and we'll deal with asymptote. So let's pretend we have here at a. And so here, let's talk about an asymptote, right? So here, if we have an asymptote, right? And we'll define how to find these. If y goes to infinity, what it means is if I have y going from infinity, so as x approaches a negative, right, and y goes to this, so a could be like 4, right? So as x goes to 4 to the power, we write it as like this, 4 negative, and then we'll write this as 4 positive. And luckily, we don't do anything else. So you can tell that means approach from the left and approach from the right. So we'll come up, and so you can kind of draw like a little, usually sometimes you'll draw asymptotic lines as dotted lines, and that way you know the function will come in and go up to infinity. And here as x approaches a positive, that means coming in from this side. All right, so let's do the same thing here. And if it approaches a negative at the asymptotic line, it'll look like this. And just come in and just dive down. Okay. And kind of like here, 0 is our asymptote, right? And so as when we approach from the left side, it goes to negative infinity. So it looks like this. When we approach from the right side, it goes to positive infinity. So sometimes you'll have them both go up. Sometimes you'll have them both go down. And the way we're going to tell from now is just kind of plug in numbers. I'll show you how to do a little bit more of that, a little something more fancy later. You're going to have horizontal asymptotes. And this is what happens when x approaches infinity and negative infinity, right? So here, a horizontal asymptote at b. So y approaches b. So let's just pretend this is b. So the function, as I go out to infinity, will approach b, but does not pass it. Or I guess it can pass it. I guess the funny part is for vertical asymptotes, the way your book defines it is these are lines which never get passed. For horizontal asymptotes, the way your book defines it is if this is b here, and I'm going to negative infinity, I can go above it, but then I'll end up flattening out to it. Okay. So you can go past the lines for horizontal asymptotes according to this book. I've seen it defined both ways. as hard lines and not hard lines. I think the way your book's defining it is more or less the general way of doing it. So here, as long as I go to positive infinity, it may pass it, it may not pass it, and it may go through up and down through it, but as you get further out, it gets closer and closer in line. And as I go from negative infinity, it may go up, may go through or pass it, but as I get closer and closer to it, it's just going to leave me out to that. So, um, so let's pretend we have a rational function of this form. This can be graphed by transforming 1 over x. Okay? And I will show you how to do that. So let's do that. Boop. Nope. I want to zoom in. Not out. I want to go in. All right, so let's do this. Let's graph this and status, domain, and range, and we're going to graph this by moving around x squared. Okay. So let's do this. So here we have our function is equal to this. So let's go ahead and first pull out the 2. And then let's go ahead and just put that in like this. And so if our original function here was, so f of x was equal to, let me not do this. Let me go back, let me go back, let me go back. I've always done the original function as the initial color, right? So if that was our original function, I guess I'll write in this for now. We can get to that function. So if this was my, let me not, that's bad notation. So if I start with this function, f of x is achieved by this function by 1 over that. And what does this mean to do to this function? It means take x 1 over x. And what we're going to do? We're going to vertically stretch it by 2. So vertically stretch it. I can spell stretch. Stretch by 2. And then this right here means somehow I made that a positive. That's not positive, guys. That's negative. And this means move to the right by 3. Okay. And so let's label stuff. So let's go ahead and so here, if we take this original function here, I'm only going to draw the original function here once, up more. It's a terrible representation of the original function. So what we're going to do is we're going to move everything to the right by 3. 1, 2, 3. And so what I'm going to draw in is the asymptote. And now I've stretched everything by 2. And so instead of going through the 1, it's going to go through 2. Does that make sense? Instead of going through negative 1, it's going to go through negative 2. So these points right here are going to be stretched up by 2. And then we go ahead and we'll wrap that in. Okay. Oops. That's fine. I actually didn't cross my line. So anything that looks like this, we can graph by just moving this around. And so let me label a couple more things. So here, the horizontal asymptote, right? The horizontal asymptote is y is equal to 0, right? Because when x goes out to infinity, it's still 0. When y goes out to infinity, it's still 0. The vertical asymptote, instead of being at x equals 0, is now at x equals 3. Okay? Or x equals 3. So here we have a vertical asymptote right here. Okay? All right. So let's do this again. And now that I'm only going to be drawing just the new function, I'm going to not use the different color. So here, we want to graph this and state, oh, I didn't state its domain and range. I do want to state its domain and range. So the domain here is from minus infinity to can't be 3, union from 3 to infinity. The range is every number I can hit. I can hit every single number, but which number? What number can I not hit in my range? What's the one number I can't hit? I'll let you guys get that to me. See if someone can guess it. 0. Yeah, correct. I can't hit 0, right? None of these numbers hit 0. Even if this was x was 10 billion, right? It'd be 2 10 billions. It's not a 0, right? And so that's our domain and range. So here we know where the asymptotes are. So the horizontal, the vertical, the domain, the range, and how to graph it. And so let's do this again. And I want you to get very comfortable with rational functions because that tends to be kind of a weaker point for calculus. So here, let's look at another rational. So we have this rational number. And we want to just do this by transforming this. Well, what are we going to do? I'm just going to divide this by this, right? So I'm going to have x plus 3 divided by, and I'm going to just do long division because it only takes a second. So I multiply this by 3, I get negative x, or x plus 15 negative, or no, that's a 2, guys. I wrote 3, this should be a 2. And then I don't even know how I got to that one. So 2 times 3 would be a 6. So here I just get minus 1. Now, if I wrote this out, right, so I can write this out. Remember how we can write this as, we could write x plus 5 over x plus 2. Remember how I showed you that? It's the same thing as eating as our quotient plus our remainder over the division. So we did this last time. We only did it once, but this is one of the reasons you would want to write it this way. So this is a lot easier to write, right? What am I doing here? Let me rewrite this one more time, just for kicks. So I'll have minus 1 over x plus 2 plus 3. And so what's happening? Nope, I want to write this bigger. I lied. I want to write this bigger so I can clearly state what's going on. All right, so this means flip, right? This means flip it over flip it vertically, right? Or that means do a vertical flip or reflect across the x-axis, right? So if I negate the function, that means flip it. This means move it up by 3. This means move it to the left by 3. By 3. And so this is just I wrote a 3 again, guys. I'm destined to put a 3 there. Is that a 3? No. This is a 2. This is left by 2. Must be Friday, right? Okay. And so now we know what to do. And so here, we're going to take this, we're going to move our horizontal asymptote up by 3. So we're going to move that up by 3. 1, 2, 3. And I'm just going to put a little dots here for my own sanity. Here we're going to move this over by 2. So 1, 2. We're going to put dots here for my own sanity. These are pretty thick dots. Okay. We're not horizontally, vertically stretching it, but we are flipping it. And so instead of being above the line, it's going to be below the line here. And then instead of being below, it's going to be above. So we're going to flip it over our thing. And so this is how this graph looks. There we go. And so this is how you graph this line. And all we did was just transform 1 over x. Let's just finish this real quick. So what is my horizontal asymptote here now is y equals 3. Because notice here as x goes to infinity or negative infinity, it's going to get closer and closer to 3 now. Our vertical asymptote is x equals to minus 2. That's the one we cannot achieve. My domain here, my domain is all numbers except for negative 2. I cannot plug that into the function. And my range here is all numbers except for my horizontal asymptote, or right? I cannot achieve it, at least in this case. At no point will I achieve this, right? At no point can I get a 3. There we go. All right, so let you guys write that down. All right, so after this, we're going to show you how to do this in a more general sense. I actually think I'm doing okay on time because let's just dive into it. All right, so what are we going to do here? So finding asymptotes of a function for a rational function more generally. All right, so the vertical asymptotes of this function here. Hi. Oh, doesn't know where I'm drawing. The vertical asymptotes of this function here are a equals x for anywhere it's 0 in the denominator. So anywhere where this polynomial gives me a 0, and we know how to find zeros for any polynomial, any real, not if you get an imaginary ones, you can just ignore those. But any real zeros here are going to be vertical asymptotes, right? And test if it goes up or down, you just kind of test the signs above it, and then you test signs below it. And I'll show you how to do that. The horizontal asymptote will occur at the following. If the upper polynomial is less than the lower polynomial, right? So the degree of the upper polynomial is less than the degree of the lower polynomial, the horizontal asymptote occurs at 0. And I'll kind of explain that when we have real examples, right? I'll explain it here why that's the case. If they're the same, it's whatever fraction this is. And notice here, that's what we had here. Here, these are the same degree, right? 3 and 1, or 1 and 1, they're both degree 1. And so we just take the coefficients. 3 over 1 was my new horizontal asymptote here. This is degree 0, and this is degree 1, and so that left it at 0. So we've already kind of seen that. If n is greater than m, there are no horizontal asymptotes. They're just not. And if m is, and if n, if the upper one is, if the upper one is greater than the lower one, there's no horizontal asymptotes. But if the upper one is just 1 higher, so this means just 1 degree higher, there's a slant asymptote. And you find that by dividing the numerator from the denominator. And I'll show you how to do that at the end. Okay? All right, so here we're going to become experts on rational functions. So how do we do this? We're going to factor both the numerator and denominator. Just makes our life easy. We just factor. Where the numerator is equal to 0, that's your x-intercepts. Find all the asymptotes using this box right here. We're going to determine the behavior around the asymptotes. And so that's what we're going to do like we did in the first section. We're just going to look at, so zeros and asymptotes. So we're just going to look at values right below it and right above it. And then we're going to sketch the graph. Okay. And so this way you can kind of be a lot more comfortable with rational functions, which tends to be a weak point. So let's do this. All right. So step one, we're going to factor this. So that's our step one. So I'm going to just write this out as step one. Step one, we're going to factor both the numerator and denominator. All right. So does this factor at all? No. So we're just going to write it as 5x plus 21, right? Does this factor? Sure. This is x plus 5 and x plus 5, or x plus 5 squared. You can write it either way. All right, so step two. So step two is set the numerator, the top part, equal to 0. That's where an x-intercept will occur. Okay, so your book asks where the x-intercepts are, so this is just something you can do. If you want to find the y-intercept, you just set x equal to 0. And that'll give you your y-intercept, which is really easy. Where's my, I'll show you how to do it. I won't even. So here, if I set the top part equal to 0, I have 5x plus 21 equal to 0. That means x was equal to negative 21 fifths, right? So my x-intercept is at negative 21 fifths, 0. Okay, and that's the only x-intercept we have. I'll quickly show you how to do the y-intercept, just because your homework asks for it. Y-intercept is where x is equal to 0, right? Right here, where x is equal to 0. Well, here, we just, that's 21 fifths. Okay, so that's 21. So here it's 0, 21, 25ths. Okay, so it's really easy to find the y-intercept. It's just whatever the constant term over the constant term. That's really easy to do. We still need this, so let's leave that out. All right, so step 3. We're going to use the above box. So step 3, we're going to use the above box to define our intercept. So, all right, so let's look what we have here. We have, in this case, n, which is my upper polynomial, is less than m, which is my lower polynomial. So here, 5x is less than x squared. That means what? The horizontal asymptote is y equals 0. So let's just write that down. So our horizontal asymptote is y equal to 0. Now, why is that? Well, here, let's say x, as x approaches infinity. So if x is 100, this is 500 plus 21. So this is 521. This is 100. 100 squared is, hold on, my brain will fire, 10,000. Yes, so 10,000. And so that easily, so even though this is 500, this becomes 10,000. So if it becomes a million, this becomes much larger than a million. I'm not going to crunch through that number. And so this becomes way much larger. And so this ends up going to 0 because this one will just grow at a much faster rate. All right, so the vertical asymptotes is everywhere. This is 0. Well, this is 0. Are the roots of this, right? Are zeros of the bottom one. Well, the zeros of the bottom one are -5 and -5. So we have x equal to -5 is the vertical asymptote. Okay. And then we just need to do step 4. And step 5 is over here. So this is step 5. I didn't leave myself too much room for step 4. But we'll go ahead and do this. So step 4. And I'll kind of show you how I do this. Let me zoom on in just a little bit because I just didn't give myself that much room. So we're going to take the vertical asymptotes and we're going to do the plus and minus of them. Okay. And so my vertical asymptote here is -5, right? So I'm going to have -5 negative and -5 positive. That means I'm going to be looking at coming in -5 at the plus and minus side. And so let me do that over here. So here would be -5. Let me put this in. So this is my asymptote right here. Here, notice here at 21/5, so a little bit over 4, -4, I have an x right here, a 0. So that's, and then here I know at 21/25, so a little less than 1, that's my y-intercept. So I know I have these points. And I want to figure out what's my behavior around the asymptote. Well, here I just want to find the sign of f of x. And then I'm going to figure out where y approaches, right? And I'm going to write this all out. Next time I'm just going to kind of find the sign and call it good, because once you know the sign, you know where y approaches. But I'm going to do everything else in very clear detail here. All right. So let's look at this. If x is less than -5, right? So here, if I'm less than -5. So here, if this is less than -5, so more negative, so like -5.1, right? Let's just use this as a test number, right? And usually I write the sign as something over something. What's the sign on the top? So if this is -5.1, my top here is going to be negative, right? Because this becomes -25. And so that's just negative. I don't even have to worry about the 1.1, right? Here, if x is -5.1, this becomes -0.1. This becomes -0.1, right? So this just becomes positive, okay? In fact, it doesn't really matter. So let's do the next one. So if this is greater than 5, right? So we'll just say, so here's a number that's slightly greater than -5 would be -4.9, right? Because -4.9 would be slightly to the right. So here, this is really close. This is still greater than, this still ends up being negative up top. And then here on the bottom, I have, this is positive, and this is positive, and so overall it's positive. So positive times a negative overall would be negative, so this goes to -infinity. So the positive or negative over positive, I think my dyslexia got me and I said it backwards last time. Okay. Another way to do this, if it's complete, I'll show you how to do this another way when we completely factor it. So both of these will go to -infinity, right? Because this number will get closer and closer to 0, but the sign will always be negative, right? Because this will always be positive, and around -5, this is always negative, right? And so this will go towards -infinity, and we just kind of sketch that in. And so this one comes up, goes through, comes back down, but what's my horizontal asymptote? Everything's going to want to approach 0. Okay. All right. I'll let you guys copy this down. So the first one may not make a whole ton of sense, but after we do a couple of them, hopefully it'll make more and more sense. So if you don't understand everything that happened right away, let's look at a couple more examples. And then when you actually do the homework, then it'll really solidify. There's an old saying, math's not a spectator sport. I think I've said this before. You can watch me do it all you want. It's not going to help you until you actually start kind of crunching the numbers. That's why usually when I teach in person, I'll do 1 or 2 of them, and then I'll have you guys do it, and then I'll walk around and dig out all the holes as you actually actively do this. All right, so let's see what our little graph looks like on Desmos. So here's Desmos. It keeps drawing and not drawing the line because it's an asymptote. And so how well did we do? Well, we did amazing, right? We did really amazing for graphing this, for saying we only checked a couple things. All right, so let's do the last 2 problems. Boop. So we're just going to do this twice more. All right. All right, right, so what were our steps? So step one was to factor this completely. So step one, factor completely. All right, so here, so we're going to factor this completely. I'm going to get 2x plus 1, x plus 4, all over 2x plus 2, x plus, oops, no, x minus 1. And this is a minus 1, sorry. I didn't factor that correctly. So 2x, so this gives me minus 4, or no, what am I doing here? Oh, this gives me minus x plus 8, so that gives me the 7. This gives me 2x squared, and this gives me the negative 4. And then this one, I assume by now you're comfortable in factoring it. All right, so we'd factor the top and the bottom. It's just something nice to do. Step 2 is we're going to find our x-intercept. I'd go ahead and just find all the intercepts right now. So the x-intercept. So the x-intercept is where the top part is equal to 0, right? So where's our top part equal to 0? Well, at negative 4, it's equal to 0. And also at 1/2, it's equal to 0. And then our y-intercept, just because that one's kind of free and we can just do it, that is negative 2 over negative 4. So negative 4 over negative 2, sorry, said that backwards again. So that is indeed 0, 2. So we have a bunch of intercepts. So let's go ahead and graph those points. So we have a point right here at negative 4. Put that point right here. We have another point right here at 1/2. Put that right here. And we have a point at 2. So let's put that right here. So we have 3 points on our graph already. All right, step 3. What was step 3? Step 3 was the asymptotes. Okay, so let's do the asymptotes. So the horizontal, let's do our vertical asymptotes. That's easier. The vertical asymptotes is everywhere this is equal to 0. Well, that would be at x equals minus 2 and x equals to minus 1 or plus 1. Whoop. Because where the bottom equals 0, we're going to have a vertical asymptote. And so let's just kind of dot that in. The other one was at negative 2, so let's do that one. So these are asymptotes. The computer. There we go. So there are 2 asymptotes. All right, so let's do our horizontal asymptote. Now, how do we find this? Let's go back to our little cheat sheet. All right, so my horizontal asymptote. So n equals to m in this case, right? Here I have x squared and x squared, so they're the same. So it's wherever a over b, so our coefficients on the top one. So this is 2 over 1, so this is going to occur at y equals 2 is our horizontal asymptote. And so we're going to just sketch that in. There we go. All right, so step 4 is we're going to do our vertical asymptotes plus and minus, or plus minus, sorry. Our vertical asymptotes. And so here we're going to have negative 2 minus, negative 2 plus, 1 minus, and 1 plus. And so we're going to look on the signs of all that. And then I am going to, let me draw that as solid line, so that just looks weird as dotted lines. Sometimes I make it dotted lines, but I didn't like how it came out. Here we're going to do the sign of f of x. And then I'll go ahead and put the y goes to here just to make our lives, just to make it clear for you guys. All right. So what I'm going to do this time is slightly different than last time. Is now that I have this factored in the 4 spots, I'm just going to say if I plug in values that look like this, what's going to happen? All right, so here, if I plug in -2 for this one, so this one represents, let me just draw this for a half second. This little circle represents this little one. This one represents this one. Let me just choose this one represents this one, and so forth, right? And so what I'm going to do is just do some test points. But sometimes the test points really aren't all that interesting because let's look at all our test points. Is this one? Hold on, I'm in a weird color now. So this one right here, x plus 4. If I'm around -2 or 1, x plus 4 is always going to be positive, right? Just always, right? So I can just put that as positive, 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 positive. It doesn't matter. Um, as long as the absolute value of x is less than 3, this is positive, right? And so I can clearly say that's always positive, right? The rest of it, not so much. So here at -2, right? At -2, even if I'm slightly more than -2 and slightly less than -2, this is always going to be negative, right? Because I'll have -2, so this be like -4 minus something. So a negative minus something is always going to be negative for these two. So that's always negative, right? Here, and then I'll go ahead and finish this before I go on. So here I have a negative and a positive, one around -2. Here, let's take this. If I plug in a negative number for this one's also going to be negative and negative, right? If I'm around -2. Here, if I'm slightly less than -2, this becomes negative. If I'm slightly more than -2, this becomes positive. And you're going to find this to be true. And I'm going to circle stuff. This is going to be the same for both if I'm testing the asymptote that came from this unit, right? Because -2 is the asymptote that came from that unit, right? And so the signs on that are going to be the same. Oops, that did not come out very clean. This should look like, okay. All right, so now what's the overall sign here? So I have 1, 2, 3 negatives. And so overall, the sign will be negative, and that means y goes to -infinity. Here, I have 1, 2 negatives. That's an odd number or even number, so that's going to go to positive infinity. All right, let's look at -1. Or let's look around 1. So around 1, this is always going to be positive, right? And so this one is positive, and this is positive. Both positives, right? Because I'll have 2 minus 1. If I have a little less than 2 minus 1, that's still positive. If I have a little more than 2 minus 1, that's still positive. Here, and let me just do a quick example in case you're curious. If I did x equals to, here I'm going to do a little bit less, 0.9. Well, 0.9 times 2 is 1.8. Minus 1, that's positive. And now I'm going to test something a little bit higher than that in my head, 1.1. That gives me 2.2 minus 1. That's still positive. Okay, so the sign of this one is positive. Remember, we don't care what the actual value is, just if it's positive or negative. Once again, for 0.9, I'm adding positive numbers plus a positive number, so both of this is positive. And notice here that these are the same when I'm testing this one, because this is the only one that says. Now, if I'm slightly here, if I'm 0.9, this overall is negative. And if I'm like 1.1, this overall is positive. So here, a little bit to the left and a little bit to the right. So this becomes -infinity to infinity. Hopefully that makes sense how I produce those. If not, just give it a try or just plug in numbers. All right, so now we have everything we need. We have what it does, how it acts, and everything. So let's go ahead and do this. So here, I know I'm going to approach, as I go out to infinity, I'm going to approach this line. I know that. As I come in, I'm going to come to the negative infinity here. So I'm going to come in from negative infinity and go out. All right, in between here, I'm going to be from, as I go up to here, it's positive infinity, and as I go close to here, it's going to go to negative infinity. So I have some positive infinity thing coming in, going down to some negative infinity thing. And it does not cross that line. So I have something that looks like that. And then from here, it starts at it. So here I'm starting, as I approach this line, I'm going to positive infinity. And as I approach this line, I'm going to go to my asymptote, which of course is 2. All right, so let's see how we did. This is the longer of the 2 sections. All right, so let's see how we did. I'll let you guys copy that down as I write it out. Minus 4. Oops. To be divided by x squared plus x minus the 2. I was like, that don't look like what I have because I forgot an x. Ta-da. When I originally typed this in, I had it look like this. Like, that's not right. I forgot the x. So please double check what you typed in the computer. Now, how did we do? Let's see how we did. Let's zoom on in. Does this look a crap ton like our graph? Yeah, it does, right? Here we're at 2, 5, 4. Notice here it does not. It reached -2, and it looks very much like we predicted it would look. Okay? And so this is an amazing way to graph rational function by hand. All right, we're going to do this last one. And now that we know all the steps, I'm just going to kind of go through it at a... Okay, so let's go ahead and do this. So step 1, we factor. The bottom's already factored. The top part just factors in the x minus 5, x plus 1. And here we just leave this as x minus 3. All right. Step 2, we're going to find our intercept. So we have our x-intercept. We're going to have our y-intercept. All right, so our x-intercepts here are where the top part is 0. So it'd be at -1, 0, and then at 5, 0. So those are 2 intercepts. Our y-intercept is just -5 over -3, so that'd be 0, 3/5. Okay, so 0, and let's go ahead and plug those in. So 0, 3/5 is, or 5/3. Wow, my brain's really just flipping everything today, isn't it? It's 5/3, so 5/3 is about here, I suppose. So -1, 0 is one of our intercepts. We'll put that in right here. We have another intercept here at 5. So 1, 2, 3, 4, 5, right here. All right, so step 3, we want our asymptotes. So we have a vertical asymptote, which is the easiest one. Where is this equal to 0? And x equals to 3. So here at 3, we're going to type that in. I'm going to hit this button right here. See if I can't make this a little bit. Yes, I see how I can make this a lot lighter now. There we go. Click off that button. So it's a little bit finer of a line. And then we'll hit H, horizontal asymptotes. Do we have any? Well, let's go find out. From here, our top one, our bottom one is less than a top one. So there's no horizontal asymptote. But it's less than by 1, so we have a slant asymptote. And let me show you how to find that. All right, so it has no, so we'll just write none. But it has a slant asymptote. So slant asymptote, and we find that by dividing. So here, I'll show you how to do that. You just take x minus 3. We divide it by x squared minus 4x plus 5. I'm doing this long division because sometimes this will be a cubic, and if it's cubed or or quadratic or quartic, you have to do long division. The synthetic division only works for linear things, and this works here fine for linear things. Just for the sake of time, I'm going to give you what the answer is. We're not going to crunch through it. Okay, and so when you factor this, this is what you'll get, right? This right here, your quotient right here is your slant asymptote. Basically, you set y equal to q of x, okay? Which in our case is x minus 1. So y equal to x minus 1. Here, I'm going to just draw it in like this. Just do a real light line. So if I can aim. And so we have this weird asymptotic line that looks like this. Okay. All right, so now all we need to do is determine our behavior. So let me put stuff over here. So here we'll have 3 minus, 3 plus. And here we're going to just do our little things. So here's just an abbreviated version. So around 3, this will be negative for both of them. So this is negative, this is negative. Here, this will be positive for both. The only one that switches is the bottom. If I'm slightly less than 3, this will be negative. If I'm slightly more than 3, this will be positive. And so we have 2 minus, no. This goes to positive infinity. And this one goes to negative infinity. And we just count up even. So we have even number of negative signs, and here we have odd number of negative signs. So now we know everything to graph this. So it's going to kind of follow the asymptote and then go through this and then head up to infinity. And then this one's going to come in following the asymptote and then go out following the asymptote. And let's just see how we did. It's negative 5. On the division. Oh, thank you. I was like, where's its negative 5? Thank you. I'm here. Sorry, I just copied that over. You did a division. You'll get this. It's the same answer. I pre-did the division. Thank you for correcting that. All right, so let's see how we did, and then we're done for this section. All right, so we have x squared minus 4x minus 5. And then we'll have x minus 3. Ta-da! And how do we do? Not bad. It's a little. I have it a little bit more out. Well, I guess so. I zoom into the same scale. No, we did real good, right? If I zoom into the same scale, we did real good. And so here you can easily see how to, or not easily, but you can see the process of how to graph any rational function, how to find asymptotes for rational functions, which are super useful for solving problems and doing things, and you can determine behavior. And then when you do this sort of thing in calculus, you're going to say, well, when x goes to infinity, what happens here when x gets really close to 0 from the left and the right? And that's all about limits. And so a lot of limit stuff deals with this. So this will just get you ready for calculus. All right, well, that's the end of this section.